Hi everyone, this is Lavanya from Department of CSE and this is the continuation of deadlock detection. Okay, in this, as I have said, now we are seeing the single instance of resources and deadlock detection. Okay, in this, for a single instance, we will be using wait for graph for detecting the deadlock. The wait for graph is constructed from resource allocation graph. Okay, now let us see. In this, the process P1 is holding the resource of is requesting the resource of R1, whereas R1 is getting allocated for process P2. In such a state, P1 will be allocated by the resource R1 after completion of the process P2. So we are directly connecting that P1 is waiting for the completion of the process P2. P1 is depending on process P2's completion status. So it is denoted here as P1 to P2. Then from P2 is requesting for the resource R3 which is held by process P5. So in this P2 depends on the process P5 completion. So it is denoted as P2 to P5. Then from P2 is requesting for the resource R4, whereas R4 is getting allocated or used by the process P3. So after P3 completes the execution of the usage of the resource R4, it will get allocated to P2. So we are directly giving this H as P2 to P3. And here P2 is requesting for an resource R6, whereas resource is held by P4. So I am directly giving the H of P3 to P4. Then P4 is requesting for a edge of R2, whereas R2 wait a second, P4 is requesting for R2, R2 is held by process P1. So it is indicated as P4 to P1. Okay, here I have given a direct link from P2 to P4. Yeah, here I have seen, right? P2 is requesting for R5, whereas R5 is held by process P4. So there is also another H. Okay, this is the complete construction of wait for graph. As we have discussed earlier, if a cycle get formed in a wait for graph, that too this is a single instance of resource, right? So there is an occurrence of deadlock. Let us see whether there is a formation of cycle. In this, the process P1 to P2, P2 to P3, P3 to P4 and P4 to P1. This forms an cycle. In the same way, P1 to P2, P2 to P4, P4 to P1 also forms an cycle. Only P2, P3, P4 doesn't form an cycle. Okay. Here are two cycle formation. So there is a possibility of occurrence of deadlock. Since this is a single instance of resource, if a cycle gets formed, as we have already seen, if a resource is getting allocated in a cyclic order, then there will be a possibility of occurrence of deadlock. Okay, now as a continuation, we are going for an several instance of resources. We have already seen the resources might be of single instance or it might be of multiple instance. For single instance, usually we will be using resource allocation graph for deadlock detection and deadlock prevention, and for deadlock detection we will be using the wait for graph. For several instances of resources, the deadlock prevention and avoidance will be using of Banker's algorithm. We have already seen Banker's algorithm and deadlock avoidance. In that, we have seen if we must construct and allocate the multiple instances of resources in an safe state, and we have found the safe sequence in the numerical problem. If the system is allocated within safe sequence, then the system will not fall into the deadlock situation. That is the concept of Banker's algorithm. Now we can see the deadlock detection for several instances of resources.